Mm, mm.
So very good evening to all members gathered here. Today we are in the next lecture on engineering graphics. So in that we are going to discuss about isometric projection. So what is meant by isometric projection and what are the special features present in isometric projection? So these informations we are going to discuss today under this topic. So isometric projection is a technique followed for visually representing the three-dimensional object in two dimensions. So it is mostly used for technical and engineering drawings, isometric projection. And this is one of the type of axonometric projection where all three coordinate axes appeared equally shortened and the angle between any two axes considered to be 120 each. So the isometric angle will be 120. All the three coordinate axes heading towards x, y, and z direction equally will have 120. What are the various key characteristics of isometric projection? First one is equal foreshortening. All the three axes say x, y, z are foreshortened equally, meaning they appear to be of same length, even though they are projected onto a 2D plane. Single view projection. All the three dimensions of the object can be represented in a single view so that user can feel much easy to visualize the overall appearance of the object with respect to shape and spatial relationship. How isometric projection works? Let us see the further information. So the main thing to be defined for an isometric projection is axis. Imagine there are three axes x, y, and z, and which are intersecting at an angle 120 to each other. Next one is lines. The lines that are parallel, drawn parallel to the axis called as isometric lines. Non-isometric lines. The lines which are not said to be parallel, that is referred as non-isometric lines. The next one is plane. The plane formed by two isometric axes, joining two isometric axes called isometric plane. And normally they appear at an angle of 30 to the horizontal. So what are the usage of isometric projection? Isometric projection is widely used in various fields including engineering and architecture. Then next one, computer graphics, gaming environment, then technical drawing. So these are the areas where we can able to utilize the isometric projection. Now let us see a simple demo about the isometric projection.
Mm, mm,
Hi guys, greetings of the day. Myself Vijay Tavardhan, and in this video session, we are going to discuss about the construction of isometric projections. And an example problem is like this. Following figure shows the front and side views of the solid. Draw the isometric projection of the solid. So, according to this, one can see that we have a cylindrical slab of 30 millimeter for a 60 millimeter length is connected to another square slab of 30 millimeter and height 60 millimeter. Now let me show you how to construct the same. So using a line command with thickness of 0.35 millimeter. So we will construct a 30 mm square shape first in the isometric projection. So 30, 30, 30, 150, 30 minus 150, then 30 minus 30. And then from the center of the square, we need to locate the height of the solid as 60 millimeter using the chain line for 0.1 mm thickness. And I'm going to select this square, and the same square is going to be positioned at the top base over here, and then make use of a line command with a thickness of 0.5 and a continuous line. So one can draw the construction lines like this. This is nothing but the visible edges, and then the invisible edges we can delete it, and then we can complete this construction. And after which, one can see that this is going to be required 30 by 30 mm square of height 60 millimeter, and after which we have to construct the cylindrical slab. So now to construct the cylindrical slab of 30 millimeter, what I'm going to do, I'm going to select this square along with the axis. Then using the move command, I'm going to position it somewhere over here, and then using the line command with a thickness of 1.3, 0.13 millimeter. Then let me construct the ellipse over here, which is going to represent the circle in the isometric projections. So now this is the construction which is already we have discussed in detail how to draw the same things using the 4 arc methods. So the ellipse here, what we are going to construct is with respect to the 4 different arcs. That's why it is called as 4 arc method. So we have drawn two different arcs already. Now the third arc we are already on draw. Now 3, and this is going to be the final arc that we are going to draw now. Now, after drawing these 4 arcs, so all the construction lines which are not required can be deleted, and then whatever the ellipse is there, we are going to select this ellipse and make the thickness of the ellipse as 0.5 millimeter, and the same ellipse is also supposed to be at the bottom over there. So now, for a while, we will not delete these construction lines. It is required for a while. And let me have this construction lines, and the thickness of construction lines is 0.13, and the ellipse whatever we have will have an ellipse. Then make use of the move command and move this ellipse for the bottom portion from here to here with the move copy on, and the thickness of the ellipse is supposed to be 0.5 millimeter on either sides. So now let me change the ellipse thickness to 0.5 millimeter, and then using a line command with a thickness of 0.5 millimeter, one can draw the cylinder boundary like this. Now after which we can rotate the cylinder into a horizontal cylinder using a command called as rotate in such a fashion that this is going to be a vertical edge like this. Now the rotation angle is going to be 60 degrees. Now using a move command, move this with respect to this end point or the midpoint of a line, which is supposed to be positioned on the midpoint of the 60 mm line over here like this. So once this position is fixed, then zoom the area, and then whatever the construction lines are there, those construction lines can be easily selected and deleted, which is not required. Then using the trim command, whatever the invisible portions are there of both the solids can be trimmed. Now, you can see this is all going to be the required isometric view or isometric drawing. Now, selecting this figure using the scale command with the scale factor of 0.1864, we can convert this drawing into isometric projection like this. Now, one can say that the isometric projections of the given combination as shown in the figure is completed. Now, if you are having any sort of doubt to solve this problem, please feel free to contact me at any point of time.
So we have observed the demo tutorial on isometric projection of basic solids, combined solids with a video demonstration. So with this view information, so it is known that isometric projection provides a clear 3D representation of an object on a 2D surface and making it a more valuable tool for better visualization and communicating design and construction details of the object. So once again, I thank each and every one of you. We will meet in the next topic under the same subject, engineering graphics. Thank you all.